Hello fellow pre-service teachers, my name is John and welcome to my first of two videos for my Maths Curriculum Studies 2 submission, and in this video I'll be doing the video work solution to the question that I was allocated, which is hikers. And just to summarise this question, a group of hikers march out from their starting point and the maximum distance away from their starting point can be modelled by this function here. The distance equals at squared brackets b minus t, and t is the time in hours, and a and b are unknown variables. So just to illustrate this graphically, on the right we have time on the horizontal axis, distance on the vertical axis, and this is a cubic because when I expand out the t's it'll become t to the power of 3. It could look something like this, let's say, where this is the maximum distance away from the starting point and this is time. And the objective of this question is to find the maximum distance that the hikers are away from their starting point in terms of A and B. Because I just clarified this question with Bevan, it looked like it had been taken out of a textbook and had some information missing. So the point that we got to is just find the maximum distance away from the starting point in terms of A and B. And in order to solve this question, you need to understand the concepts of functions, rates of change, so how to derive a function, and optimization, which is what do turning points of functions mean, gradients of tangents, for example, and how we apply that understanding to find, say, the maximum distance or the maximum speed, etc. And I'm going to be touching on these points more in video 2 and how they tie to the Maths B syllabus. But for this video, we're just going to be solving it. So to find the maximum distance from the starting point, I'm going to derive the function. So just to summarize what I'm going to do, max distance occurs, just misspelled that, when the derivative, so d dash t, is equal to 0. And just to briefly explain why that is, this function here that I've shown on the top right, this is the distance away from the starting point. At this point here, the gradient of the function, so we'll call that m, is equal to 0. And so when the gradient of the function equals 0, that'll give us our maximum point. So we need to find the derivative of the function. I'm firstly just going to rewrite the function. dt equals at squared brackets b minus t, and then I'm going to expand it out to make it easier to derive in the next step. So it becomes ab t squared minus at cubed, and the derivative, we'll just go through and derive these two terms here. This becomes a b t, that's just to the power of 1, so just t, subtract 3a t squared. And I'm going to make this equal to 0 because that will give me my, this will give me my time, because I'm going to solve for t, and that'll then allow me to sub it back into the original function and find my maximum distance. Now I have a quadratic equal to 0. I want to solve for t. There are a number of different ways that I could do this. I could use the quadratic formula. However, because there's no constant, I'm just going to factorize and use the null factor law. So to factorize this quadratic here, a and t are the like terms, so it'll become at outside of 2b subtract 3t, make that equal to 0. Now with the null factor law, either this term here or what's in the bracket will equal 0, because we have two numbers or two terms multiplied by each other that equals 0. However, this left solution is not an option. And the reason for that is at can't equal 0 because time can't be 0, because when they're at the max distance there's going to be some time, and a can't be 0, otherwise this whole function will equal 0 because a multiplies through the lot. So therefore this is the right hand side, the one that's in the bracket, is what we're going to work with. So 2b subtract 3t equals 0, rearrange and solve for t, 3t equals 2b, t equals 2b on 3. So this time here, 2b on 3, is the time where the hikers are the furthest away from their starting point. Now, to find the equivalent distance, I just need to sub t equals 2b on 3 into my original function, dt. So d outside of, the distance when t equals 2b on 3 is equal to a 2b on 3 all squared, and then b minus 2b on 3. Now we just need to go ahead and use some algebra here and present this in a nice final answer. I mean, this is an answer here, but I want to give it in a cleaner answer. So let's go ahead and do that. A, using indice laws, this will become 4b squared over 9. And I can write this as, I'll put it all over a common denominator. I'm going to multiply this a by the first fraction, so it becomes 4ab squared on 9 outside of, now 3b subtract 2b on the numerator just creates b over 3. So finally this will become 4ab cubed on 27. Okay, so there we have it. There is our answer. In terms of A and B, this is the maximum distance that the hikers are away from their starting point. And in the next video, I'll be talking about how this question ties in with the Maths B syllabus.